Welcome to cyclical integration by parts. So the general idea here is, while so far we've only seen rapid repeated cases where the left side went to 0. Right? So far we've only looked at cases of rapid repeated integration by parts. Where the U column went to 0. But sometimes we never actually hit 0. So sometimes the U column never goes to 0. And so the question becomes, how do we finish integration by parts? So the most common places where you run into this issue are with cosine or sine multiplied by an exponential. So let's go ahead and look at evaluate the indefinite integral, the integral of e to the 2x cosine of 3x dx. So let's go ahead and just try rapid repeated and see what happens. So we'll go ahead and try rapid repeated first. We can pick either e to the 2x or cosine 3x as our u. Personally, I prefer to differentiate cosine as opposed to integrate. I'm less likely to make a sign error. So let's go ahead and take our u to be cosine of 3x and our dv to be that e to the 2x, again, technically times dx. Then if we differentiate on the left, we'll go to -3 sine of 3x, followed by -9 cosine of 3x, followed by a 27 sine of 3x, followed by a 81 cosine of 3x. And you can see that left-hand side is just going to continue to cycle through sine and cosine. The right-hand side will go to 1/2 e to the 2x, then to 1/4 e to the 2x, then to 1/8 e to the 2x, and to 1/32 e to the 2x. Essentially, we're never going to get rid of either a cosine or sine times e to the 2x. So we are permanently stuck with cosine 3x or sine 3x times e to the 2x. That's not particularly helpful when you want your rapid repeated to end. So if we look back at our table, note that if we did use the integral from that second row, the -3 sine 3x, 1/2 e to the 2x, that's a new integral from the problem. But if we go to that third row, the -9 cosine 3x and 1/4 e to the 2x, note that integral is just a scalar component of the original integral. So note the product of row 3 which is negative 9/4 cosine of 3x e to the 2x is just a scalar of the original function inside our integral. And so what we're going to do is we're going to stop at that horizontal row's integral. We'll stop at that row. So I'm going to rewrite the integration by parts. So our u and dv, we had cosine of 3x for our original u, e to the 2x as our original dv minus that dx component. Differentiating down the left, we go to a negative 3 sine of 3x, followed by a negative 9 cosine of 3x. Going down the right, again, we had a 1/2 e to the 2x, followed by a 1/4 e to the 2x. We add the first diagonal, we subtract the second diagonal, and then we are going to add, keeping that opposite sign trend, the integral of the bottom row. So we are looking at the integral of cosine of 3x times e to the 2x dx is equal to cosine of 3x times 1/2 e to the 2x, there's our first diagonal, minus a negative 3 sine of 3x times 1/4 e to the 2x, there's our second diagonal, then plus the integral of a negative 9 cosine of 3x times 1/4 e to the 2x dx. Rearranging this, we have that the integral of cosine of 3x e to the 2x dx is equal to 1/2 cosine of 3x e to the 2x plus 3/4 times sine of 3x e to the 2x minus 9/4 times the integral of cosine of 3x e to the 2x dx. At this point, it's just algebra. We're going to solve for the integral, right? So we're going to solve algebraically. For the integral of cosine of 3x e to the 2x dx. So here's one term with that integral of cosine 3x e to the 2x dx. Then we have a second term that was our minus 9/4 times the integral of cosine 3x e to the 2x dx. If we add that 9/4 cosine to both sides, or 9/4 integral, so we have the integral of cosine. Actually, I'm going to make our lives easier by setting this integral equal to a. So we'll solve for capital A, which is our integral of cosine 3x e to the 2x dx. So this becomes a equals 1/2 cosine of 3x e to the 2x plus 3/4 sine of 3x e to the 2x minus 9/4 times capital A. If we add that 9/4 to both sides, we wind up getting 13/4 times A is equal to 1/2 cosine of 3x e to the 2x plus 3/4 sine of 3x e to the 2x. And therefore we get that our A is multiply both sides by 4/13. We get 2/13 cosine of 3x e to the 2x plus 3/13 sine of 3x e to the 2x. But A was our integral, and so we get that the integral of cosine of 3x e to the 2x dx is simply 2/13 cosine of 3x e to the 2x plus 3/13 sine of 3x e to the 2x. And then of course we have plus c. Anytime we have this case where our rapid repeated integration by parts is just kind of going cyclically on forever, then we can simply stop when we notice a repeat row that's only off by a scalar, and then solve for that integral. I recommend swapping it out for some capital A or whatever letter you want, whatever symbol you want, just so you can shorthand it. It's a little easier to recognize what you're solving for them. So we will go ahead and do one more example in the next video of a cyclical integration by parts.